I am live. That is pretty nice. And today is 6th of October 2025, Monday. And today we will give a virtual contest. That is pretty nice. Yesterday was a contest. And now we will give virtual contest for the same. That is cool. Uh, yeah, cool. Virtual contest, code forces, and yep, the stakes are going to be the same. Not the stakes, but the mental state is going to be the same. And yeah, it will start in 2 minutes. Individual register for virtual participation. Cool. Shit, I have to set up everything. I have to set up this 1056 contest number, start Vim, and that is all the setup that is needed. Hello, how's everything? And yes, right now we are giving a virtual contest which will start in 1 minute. And yeah, this contest was just like yesterday, and today we will give virtual contest for the same. English, yes, I am improving my English. Virtual contest, and like the mental state should be will be the same as if we are in an actual contest, because what is the point if we don't take this seriously? So yeah, we will take this seriously and do our best. Right, drink some water and begin. And I am doing Java full stack. Why are you doing Java? Like, I don't know why you are doing Java. You are 17-year-old, so you can. It would be much better to do C++. Okay, we are in a contest. Cool. Now, Juan and his friends are going to split themselves into N teams and play a modified double elimination football tournament consisting of a winner groups, and there are going to be N teams and a losers group. Initially, all teams belong to the winners group. Okay, and okay, in each round of the tournament, the following happens as long as one of the groups has at least two teams. All the teams in the winners group pair up. If there is an odd number of teams in the winners group, there would be a team that didn't get paired up and wouldn't play a match. That team stays in the winners group. For teams in the winners group that did got paired up, each player plays a football match and which have no ties. If the team wins, it stays in the winners group, and if it loses, then it is dropped into the losers group. In the next round, all teams in the losers group pair up. If there are some teams in the losers group, if there is an odd number of teams, pair up and wouldn't play a match, the team stays in the losers group. For all the teams that were pair up, no ties, team wins, they stay in the loser group. If a team loses, they are eliminated from the tournament. Okay, note that in the above process, when a team loses a match in the winners group, it drops down to the losers group in the next round. That means it is not considered for pairing process in the current. It is not considered for the pairing process in the current round of losers group after multiple iterations of the aftermath. When this happens, both teams face off each other in a final match, and a victor emerges. Determine how many matches were played in total. It can be proven that no matter how the teams are paired up, okay, the number of matches that were played, if there were initially n number of teams, all are in the losers group, half of the teams will go in the second group. If n is the highest power of, no, we take n, divide n by 2, and n by 2 lower limit, teams will go in the losers group, right? And n by 2 upper limit will stay in the winners group, right? So yes, we will have two numbers. And while, yes, and in the next iteration, yeah, we can just simulate this, right? Yeah, we can simply simulate this thing. And cool. Okay, we can simulate. Okay, this is the actual count. Wait, that was question number C. Shit. This is the question. We are going to simulate. Shit. Contexts are different. Okay, winner equals n and while winner greater than 1. So, and there must be a formula for this, like a direct formula. We can do this. Okay. Matches plus equals. How many matches will there be? There will be winner by 2 number of matches. And in the losers group, there will be loser divided by 2 number of matches. And after this round, winners will be equal to uh, winner plus 1 to get the upper bound divided by 2, and loser will be equal to loser plus 1 divided by 2, the upper bound. And yeah, this will happen while winners and uh, yes, and also losers will get some more thing. This equals winners by 2, lower one. uh, and new L, new loser, winner divided by 2, update loser, and winner loser plus equals new loser. And this will happen while winner is not equal to 1 and loser is not equal to 1, after which match plus, yeah, see out, match, a new line. And yes, I'm not looking at the chat at all. Match, wrong answer for the second one, because 3, one person will go in the, this increases the answer by 1, and new, this should be 1, so loser will become equal to 1. Huh, right. And the new winner should be winner here was equal to 3, new winner will become equal to 2. Yeah, there will be 2 people in the winners group. Okay, okay. While winner is not equal to 1, I think when winner is equal to 1, Winner will be cool, cool. I think this should work. This should work. This should work. This should work. Will this work? It has been 9 minutes. Shit. Yes. I'll look at the chat. 9 minutes. Okay, cool. This should work. Hopefully. Okay, cool. On to the next question. What are the standings? What's up? Hello. So do you want to grow as a YouTuber? I want to grow as a person, and if getting better at YouTube is a consequence, then that is pretty cool. Oh, you can work with me. That is pretty nice. From I am studying, I am in college currently, but I do not have a standing. I do have a standing. Shit, bro was much. Okay, he gave one wrong answer. Okay, now here, Ibrahim is a brave explorer who goes where no other programmer has gone before. For his expedition, he plans to investigate a particular maze. He knows the maze is an by grid in each cell that points in four directions up, down. Abraham knows that if that is a reference. Abraham that if he stands on a arrow, he will be forced to follow the arrow starting from that cell. Okay, and in each cell the points with an arrow which points okay in four directions, possibly four directions. Each arrow moves Abraham exactly one cell in that direction that it is pointing. If he reaches an arrow that points towards the outside of the maze, Abraham will escape the maze. Abraham doesn't know how the arrows are arranged, so he wants to plan for multiple scenarios. He asks you with finding an arrangement of arrows in the grid such that there are exactly key starting cells from which he can escape the maze. From which he can escape the maze. Key starting cells, and the maximum number of starting cells is going to be 4n 4n minus 4. 4n minus 4 are going to be the total number of starting cells, and k is less than n square. Okay, they can be also internal. Make all of them up. Here there are in total 9 cells, and I want 5 of them to be working properly. I can start putting them in a row. My grid is going to be a 3 by 3 grid here, and I want 5 of these to work. I can always make 5 of these cells like this, and if I begin, these are all pointing up. If I begin from any one of these, then they will work, but I need to make all the remaining cells not work. Right, left, up, down. They will just alternate between each other. Or in generally speaking, the shape that is left is going to be somewhat like this. And what we can do is if there are And also, is it sometimes possible that the answer is not possible? For each test case, the integer of arrangements. Wait, should that is C? Yes. And if not possible, then no. And answer is not possible here because the remaining number of cells is odd. Yes, they have to be pointing to each other. Can the arrangement be achieved with 3 cells? What if k was equal to 6? In this case also it would be possible. The answer would be possible also in this case. We could make this also a up, and all of these, yeah, shit, cool. All the things in a row are going to be up down, and if there are some things here, they are all going to be right. Yes, except, yeah, if I have just 2 cells left, then it is going to work. Cool, okay, we can do this. That would be nice. Which college? A third tier college near my house, near in my city. And N and K, C in N and K. And what do we have? N and K. Okay, N is at max this vector of string size N and a string. While for, let's make everything initially. Yes, we can do this. Strings will have size length N and everything is like up, pointing up. And now this K and N equals 3 and K equals 5 in an example, and we need like everything in this sum section is going to be up. And also, yes, if N into N minus K equals 1 equals 1, then see out no. See out no. And now we have to see the starting cell, the upper bound. This is 0. Cell number 0. Okay, in when n equals 3, this is our original grid, and 1, 2, 3, 4, 5. We need the index of this. Since k equals 5, we need the index of the first column that is not equal to 5, and we will start our journey from here. We will make all the things in this column equal to right, and all the things in all the right columns here, everything in the first row, except if n equals 1, then yeah, then it is like messed up. Yes, and everything here will point up, and everything in middle can be anything, up down, anything, does not matter, and all of these have to be right. Okay, and so we need the index of this thing. That is all we need, index of this particular cell, and there is only going to be one column which is excluded from being counted as a k. Yes, and this should be k n square divided k divided by n. That would give us this I. Yes, that would give us the I, and then remainder k modulo n will give us this cells column, which in this case is 2. Okay, and I equals k by n, and j equals k modulo n. And for j is already same, j equals k modulo n, j smaller than n, j plus plus. We need to do res I j equals right. And yeah, that is done. I plus plus for I is already initialized. I less than n, I plus plus. Let's make the first like top row equal to down and the last row equal to up. First of all, yeah, let's do that. No, we can handle it here. For int j equals 0, j less than n, j plus plus. If not j, right? If we are at if it the whole coordinate system is messed up. Shit, I is this. Okay, I messed up I and j. I is this, not this, and j is this. Shit, I messed up the coordinate system. So in this case, it is I that is changing, and j is the column that is fixed. And here, therefore, we do j plus plus. And yes, we don't know which this to begin with, but we do know the column with which to begin with. For int I equals 0, I less than n, I plus plus. If not I, if we are at the top row, then res I j equals down. And else if I equals n minus 1, we are at the last row, res I j equals up. And no, not just up here, up in n case would be fine. And here column that we got was very nice. And after this, we out. Yes, this is very much possible. And for row by row, int I equals yeah, for int I equals 0, I less than n, I plus plus, C out rest I with a new line. Here, shit. Wait, no, this is wrong. Yes, this is wrong. This is wrong. I equals this. Up, right, up, down. Okay, cool. This working, this is working, and rest initially everything is up. And actually, we don't even have to do all of this up because everything initially is already up. Shit. So we don't even have to do this. We can just say res 0, up, down, right, up. That is crazy. Okay, this should work. This should work. This should work. This should work. Yo, hello. Hello. Hello, Bruno. First problem I have is strings formula n into 2 minus 2. Yes, okay. K divided by n. K divided by n. If K is the number of cells that need to be that. Yes. Sorry, I will look at the chat just now in a minute. K he can escape, and if there is exactly one cell from which he cannot escape, then no. But for every other configuration, this is going to work. Vector string, everything initially is equal to u upwards, and int j equals k by n to get the index. Yes, that is also correct. Yes. If j is smaller than n. Or we are not actually checking anything here. If j is smaller than n, okay, because k could be equal to n square. Yes, in that case, yes, that would be the case when we do not have anything. Yes, when we do not have to change any cell. And in this case, we are going through the row, okay, and then in the next row, while j is smaller than n. Yes. That also makes sense. If j equals the last row, which is n minus 1. Shit, I don't even have to do this. You don't have to do this. In this specific row, res I, I, k remainder n, j equals down. And when we have n equals to 3, one test case, n equals 3 and k equals 3, 3, 6, 7, let's say. Yes, you down, up, okay, cool. Shit. Yes, cool. This should work. Hello. I've been seeing you post these live streams for a while now. Just dropped in to tell you, keep it up. Yes, I will keep it up. Thank you for that. Determination is pretty inspiring. Thank you for. Okay. Okay. Shit. Yes. Oh, shit. Okay. Yes. Shit. Yeah. So our approach was pretty better. If shit. And shit. If remainder equals n minus 1, then res n minus 1 j equals r, and set, right, go r and up. Shit. One test case 3 and 5 7, up down. One test case 3 6, that is also working. Two wrong submissions is too much. That is just too much sadness. One test case 3 5 4. Yeah. Wrong answer on test case 1. That is pure stupidity. What tools are you using for terminal? I am okay, cool. That is nice. I'm using NeoVim, and I'm working on Tmux. Yes, I'm also using Tmux and NeoVim. That is pretty cool. Okay, I do not know what is F switch. I'm trying to build a simple development environment, and that is cool. You can make different sessions, and you can even automate your sessions using tmux script. That would be pretty nice. And vim is just amazing. You can add plugins which will make your environment pretty easy. And in the first problem there is a formula. Shit. I simulated the first problem. I think that is not very good. And shit, this is not very good. This is not very good. Okay, 2000 is good. 30 minutes for the second problem is not good. Let's go to the third problem. Let's see if we can do 3 problems. That would be pretty nice. Okay, a lot of people are stuck on this problem. Okay, shit. There are n wizards in a row numbered from 1 to n. N wizards in a row numbered from 1 to n. Each wizard has an invisibility cape which can be numbered 1 to n, left to right. 1 to n, left to right. Each wizard has an invisibility cape that can be worn either on his left side or on his right. Harry walks from position of wizard 1 until the position of wizard n. From left to right, registering how many wizards sees, how many wizards he sees from each wizards. Key, a wizard on position J is visible from I if wizard J wears a cape on his left side. Is visible from position I if I is on the right on the point of J. If J is wearing his cape from on the left side and I is on the right, and if I is on the left and the cape is on the right, then also J is visible. In a particular note that I is in particular note that wizard I is visible from position I. Yeah, it is possible visible from itself. Harry's list is very old, but after much work, he managed to decipher it. The list is in a array A of n elements where ith element AI the number of wizards that Harry saw from position I. Your task is to determine how many possible. Shit, that is difficult. That is kind of difficult. So at a position, he is saying how many things are visible on his left, and how many things are visible on his right, which just means how many, when he is here, on the left, how many wizards have their cape on the opposite side, on the like right side, and in the left subarray, how many wizards have their capes on the left side, +1, because he can always see the wizard that he is at. Okay, that is kind of tough. Let's do this. We have a lot of time, 1 hour and 25 minutes. We can do this. Yep, perfect. Thanks. You're welcome. A switch is for monitoring files and okay, FS switch. FS watch, file system watch. Okay, shit, I read it as F switch. File system watch is for monitoring files and folders. So if you make a change in your source file, it compiles automatically. That is pretty nice. Shit, and you would also be able to configure this. And that is why you would need it in a development environment, so that whenever you save some change in a file, your whole project compiles automatically. That is pretty cool. Okay, thank you. You too. Have a good day. And this is bad. This is bad. Look at this. Okay. Here we have this, and this says, okay, what is the most forcing thing? Okay, this is saying that everything on the right have their capes on their right. So for this saying, this is telling us that every wizard on the right have their capes on right. So that is kind of fixed. And this is telling us that everything on the right have their cape on right, and everything on the left also have their cape or have their capes on the left. So there is only one possible configuration for this one. No, there is actually two. No, there is actually just one possible configuration. For this one, there is zero configuration. Modulo this. Okay, we just have to see what is the most forcing one. Yo, CO stuff for a normal division 2. Okay, let's see. Let's see. C does seem tough. Okay, so if we just see whatever is the most forcing one here, using this, we have fixed the state of all the things to the right. So they are all fixed. And this is the only variable that we know about. And when we are here, we have fixed the state of this one. So everyone's state is fixed. And when we are here, this is this guy can only see 3, which means, shit. He can, this 3 also includes the current wizard at the current position, and the sum of the wizards on the left which have their capes on the left plus the wizards on the right which have their capes on the right is 2, which actually is true. Here we have 1 and here we have 1, so 2, cool. And 2 for this, and since we do not have anything on the left On the right, we have just one. There has to be one wizard on the left which has their keep on the left, which actually is true, this one. So there is only one possible configuration. We also have to check for there might be no possible configuration. So I guess shit. Yes, this is tough. This is tough. How do you even approach this after this point? Answer for this is 0. For this one, we okay, when we are here, we see that since there is nothing to the left, and yes, any number at any index x is telling us that to the left of this number and to the right. To the right, let's say there are x are number of wizards which have their cape to the right, and there are xl number of wizards which have their capes to the left, and we will have x equals xl plus xr plus 1. And in this case, xl is 0 because there is nothing on the left. Xr has to be equal to 2, which means on the right there are two wizards which have their capes towards the right, which would mean these, and they are now already fixed. Now when we are at 2, we know on the right this guy can see this guy, so 1 is gone there and 1 is here, so this one must also have its cape to the right because this guy is unable to see this guy, because if he were able to see this guy, then this should have been 3, but this is not 3. So yeah, cool. And then 3, which means this guy, this person is able to see this guy, but this one was not able to see him. So that is messed up, and I think that is over engineering. We do not specifically want to know which things are, we just have to calculate how many of these wizards can be free, which is like here. Yeah, this can face anywhere they want, and here 2 2 2 2. What does this tell me? Yeah, well, there has to be one on the right. One of these, okay, yes, shit, okay. One of these have to be facing, have to have their cave on the left. Yes. And yes, I have to place one cape on the left, and I have two possible positions to do that. Okay. And then when I am here, this and this are very same, and this is also same. Okay, I think this is one of the most forcing ones. The numbers on the corners are the most forcing numbers, and the biggest numbers are also very forcing. We can use these to eliminate ranges. This is telling me that these two, one of these two has a left and one of the other has a right, and this is telling me one of these two is left and one is right, right? And no, either both are left or both are right. That is what this is telling me, and this is telling me that one of these is left and the other one is right. Standing is going down, I suppose. It is going down. Hello, how are you doing? Probability. With a cool mind, we have already done 2 questions, so we can relax a little bit. We don't need speed with this one, we just need this to be correct. What is the information that these are giving us? Let's make a general case. For an index I is 0 index, there are total n numbers. Then there are going to be, this I index is dividing the whole array into 2 parts. Left part has a size I and the right part has n minus I minus 1 number of elements. Yes, n minus I minus 1. And yes, and what we have, and the value at I is xi, and what this xi is telling us is xi equals 1 plus 1 is just this current person. We always count the current person, and the number of people on the left which have their capes to the left side. Let's call that having left on the left side LL, and on the right people having capes on the right side. Okay, okay, okay. And we have this information, and let's say for the next one, X, we then go to the I plus 1 and we record this information, though we do not know about this much. We do not know as to the specifics of what LL and RR are actually. And there is also the wiggle room for the current element. We do not know its state. But when we start from the starting, when we are at the first element, let's say we will have a few variables L, LL, that is the number of people on the left which have a left cape, the number of people which were visible by the last person on the left, right? Initially this is 0, and RR, the number of people which were visible on the right by the last guy, and initially this is going to be equal to x0 minus 1, because for the first element there is no one on the left, so we initialize these values for the first element, and that is cool. Okay, that is cool. Then is there anything else? Yes, now we move on to the next element, right? For I, we have this much information, and we go to the next element and we get, let's say, x1. The okay, let's use one index here. We go to the next element, x2, and x2, as we know, consists of number of people left and right. So how big can x2 be? So we know that on the left we have LL, L as in like last, yeah, LL, and let's call this dash, dash. We know for a fact that this is the exact number of people on the left which have their capes towards left, and that is 0 initially. And on the right, this is the exact number of people which have their capes on the right, that is which were visible by the last person on the right. Okay, and now x2 and x1 was the last person, x2 is the current person. How much can x2's value change? The last person, this one, could have had only like two possibilities. This person could have had a cape towards left or a cape towards right. Let's see both of them, both of these possibilities. If the last person had a cape towards left, then that person would be visible by x2, In that case, we can make a prediction about this LL value, and this should be equal to the initial left people, because whatever people were visible on the left by the last guy would also be visible on the left by this current person, and LL value plus one because this guy also has a left case. So yeah, that is the maximum LL dash value we can have. And also the right value. Let's see what the right value would be in this case. RR dash. Since this is how many people were visible on the right. This would depend on the state of the current person, x2. If the current person has a left cape, then this current person x2 was not visible by x1, and now we are on that person, so one person from the right is removed. So the minimum value for r dash can be rr minus 1. Mhm. And but also there is the fact that we are always considering the current number. Hello, Chessy, bros, chess. We are also considering the fact that the current person is always visible. So if okay, shit. Okay, there are four possibilities. Four possibilities for x1 and x2. X1 could be this. Right. This means x1 had a keep on left, left, right, right, and in correspondence, x2 could have had these states. These are four possibilities which could have happened, and let's explore all of them because we can explore. We have 1 hour to do this. Okay. And what is the invariance that we have? The invariance, okay, the invariance that we have is, yeah, is L, L, or let's say L, just L, number of people visible on the left and the number of people visible on the right. They are initialized to their correct values. They are exactly the number of people which were visible on the left by the last person and the number of people which were visible on the right by the last person. Let's say that our index is 0, 1 indexed. And let's simulate when we are going from index 1 to index 2. We can always, yeah, when we are at the correct first element, L is going to be 0 because there is no one on the left, so no one is visible. And on the right, whatever the value of x1 is, the current person, x1, the current person, the first person is also visible, and the remaining person which are visible must be on the right. So this is how many people are visible on the right. Now for this case, when we go to x2 and the last person had a cape on the left and the next person had a cape on the right. In this case, how is L and R going to change? In this case number 1, L will become L dash, let's say L dash will become L plus 1, because this last person will also be visible by the this x2 person, and R dash will become R minus 1, because this person, current person that we are at x2, was visible by this x1 person because their cape was on the right, but now they are no longer visible, right? And let's go to case 2. L dash would still be L plus 1 because that cape is same, but R dash, this person was not visible before and not visible now. In the third case, when the last person had their cape on the left, so this person will not be visible now. So L dash will become L. And also in the fourth case, that would be the same because the last person is not visible by the current person. And x2, in the first case, we have that the current person was visible by the last person, but not anymore. We are at the current person. So R dash becomes R minus 1. And here the current person was not visible by the last person. So R dash remains R. So these are the only possibilities. And A, let's find the current values. And let's suppose that from all of these values, x1 to xn, we are subtracting 1, because let's say we are not counting the current person ever. So originally, x1 was equal to L plus R. Now let's calculate x2 with these possibilities. Okay, I could have written this more cleanly. Okay, in possibility 1, original x1, yeah, original x1 is always this. Let's say the new x1, new x, because these values L, R, we do not know for the next one, but what we do know is x2, and x2 should be equal to L dash plus R dash. And in case 1, let's put in the values of L dash and R dash. Hello, my name is Jatin Raghav. That is just like my channel's name. L dash and R dash. Let's put L dash is L plus R. Shit, the yeah, this plus this. And in the second case, x2, this looks like DC, this not DC. X2 equals L plus R minus 1. And in the third case, we have x2 equals L plus R minus 1. And in the fourth case, we have x2 equals L plus R. Okay, so the next value can just wiggle by at most 1. And if we were to write this in terms of the previous value, then in case 1, x2 equals x1. And okay, and this happens, x2 equals x1. This happens in case 1 and in case 4. Yes, in case 1, case 4. Okay, and we have x2 equals x1 minus 1, and this happens, and yes, this happens in case 3. And we have another case when x2 equals x1 plus 1. This happens in case 2. And what were the things in case 1? Case 1 and 4, we had left and right as these parentheses, as this for the first one and this for the second one, and this for the first one and this for the second one when they were opposite. Right. And for case 3, we have both opening to the left. Case 3, we have both opening to the left. Wait. Yes, and in case 2, we have both opening to the right. That is nice. So whenever this thing x value does not change, it means we have two possibilities. We could have two possibilities. But when x does change, increases by 1 or 2, then for these two elements, the answer is fixed. And not just that. Okay, we can now we have something tangible to work with. Let's go with this. And we will keep going through this, and we will try to determine the state depending, yeah, the state of the brackets depending on this, on these. Okay, we will start by x1. We will start from the second one, x1 equals 4, and we will start I equals 2 till n, and we will look at I minus 1, I minus 1 and I. We will look at the last one and the current one, and we will say that the current number of states is, initially it will be equal to 1. Okay, now we will compare these two. If they are equal, then these two can have any, yeah, then these two can be in this state or in this state. They must be different. Okay, let's also keep track of on the left, how many brackets are on the on pointing to the left and pointing to the right. Whenever we see this, it just means that is difficult. That is difficult. What do we even think? What do we even think about this? We just know this. Whenever we see that this value is changing, increasing or decreasing, we just know the state of the current one and the state of the last one. But Okay, yeah. Let's n can be 1. N can be 1. Let's say we will have a special case for n equals to 1. Shit. Shit, that is bad. That is very, very bad. Hello. Uh, think we are making progress. Okay, should we also have the option of looking at the maybe the next question? Batteries. Shit, this is actually kind of difficult. A lot of people are unable to do this. Maybe not. Probabilities. Combinatorics. Yes, shit. Combinatorics is bad. Shit, I'm just going to say something crazy. I mean, I don't know if that is crazy. I don't know. In combinatorics, there was a thing called Burnside's lemma, maybe something like this is used here. I don't know. Yeah, focus. Okay, initially, we will keep track of how many brackets are ambiguous. Okay, yes, we will keep track of how many brackets are ambiguous. Yes, that makes sense. Yes, we will keep track. Shit, okay. We will keep track of how many brackets are ambiguous, that is, whose state is not determined and doesn't need to be determined. Yeah. So yes, and we will start iterating from the second element, and these are the things that we know. Okay, and now there could be three possibilities. Either first and the second one are same. So let's say this many places were ambiguous. Like this is the, if we needed, this is, and this is how many states we could have. No, ambiguous should not be this. Ambiguous should be 1, because there is only one bracket that is in a ambiguous state. That is a bracket which can be 0 or 1, like which can face left or right. There is only one place. Initial place can be left or right. We do not know about it. And as we go, we will increase or decrease our ambiguous count. Now, if same, then the current bracket is also ambiguous. No, it depends on if the last bracket was ambiguous or not. LA, last bracket was ambiguous or not, and initially the first bracket is ambiguous, so true. And if we see that the x value is not changing, if it is same, and okay, let's write cases. If x I equals x I minus 1, right? That is the same. And now if LA, last bracket, was ambiguous, then the current one is also ambiguous. No, 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 no. Current one cannot be independent. If the last bracket was this, then the current bracket has to be this. If the last bracket was this, then the current one has to be this. And this is not very ambiguous, is it? Because the state of the current bracket depends on the last bracket in all of these cases. I think thing, this number that we have to return modulo this is just to mislead people. Yeah, I think this is just to mislead people. Yes. So because yeah, that makes sense. This is just to mislead people. Okay. So if we have ambiguous, then ambiguous count doesn't increase. And if the last one was not ambiguous, then also the ambiguous count does not decrease. Yes, this then also the ambiguous count does not decrease. And the yes, okay. Okay. LA, I think, is the only thing that we need. The last one was ambiguous or not. And initially we will set LA equal to true. And now we have three possibilities. First is this, six possibilities in total. If xi equals xi minus 1, xi minus 1, yes, and the last one was ambiguous, then nothing. If the last one was not ambiguous, that is, the last one was fixed. If the last one was not, okay, if the last one was ambiguous, we will keep LA as like non-ambiguous. Yeah, we will keep LA as non-ambiguous. If they are same, then yeah, okay. We don't consider this possibility because it does not matter if the last one was ambiguous or not ambiguous. It does depend. It does depend. Yes, because we will also keep track of last bracket. What it was it like open or close like this. Okay, let's actually write the code for this. I think we have this. And this, my prediction is this is just to mislead people. And the answer can be at maximum 2. That is my prediction. Let's see. C in N, vector and A by N. Take in N, and we need two things: ambiguous LA, ambiguous, last one was ambiguous or not, and int L equal bool left, or L left as in like last left, does not matter. And now we will start iterating. And also let's also have a boolean as in P. We will suppose that this is true for int I equals 1, I less than n, I plus plus. Now, if AI equals AI minus 1, if the current and the last one are same, and if the last one was ambiguous, then we need to update these two. And what is this? LA is was last one ambiguous, that is, it can be in any state. And what was the last one? And yes, if not LA, That is, the last one had a fixed state. If the last one has a fixed state, then the current state has to be opposite of that last state. So L left will become not L left. Whatever it was, it will change. And also, if last one was ambiguous, then the current one is also ambiguous, and we don't care about anything else. Else, if the current one minus the last one equals 1, right? And that would be the current one minus the last one, that is increase. X2 is x1 plus 1. That would mean the last one had must be a closing bracket, opening bracket, and the current one therefore will be an opening bracket. So first we will check if LA, if the last one was ambiguous, it is not so much. If the last one was ambiguous, we can just say LA equals false. Now the current one is not ambiguous, and L was the last one a left bracket. Yes, it was. But if the last one was not ambiguous, then it has to be left. So if L left, then okay. But if not L left, then possible equals false. And also break out of this hell. And yes, that would be the only case that we care about. Else, if AI minus AI minus 1 equals minus 1, and the same case, the last one was ambiguous, it is not ambiguous anymore, and last one must be false. Now, yes, now we are here. In this case, the current one is one less than the last one. In this case, the last one either must be ambiguous. If it was ambiguous, then we make the current one non-ambiguous and make it equal to this thing. Opening bracket, that is last bracket was not left, left false. And if the last one was not ambiguous and it was a left bracket, then we break. Now, if P, if possible, then what do we output? If possible, then we see if ambiguous or not. If everything is ambiguous, if last one was ambiguous, then output 2, otherwise output 1 if last one was not ambiguous. Otherwise, if not possible, and also else if the difference is like other than this, then P equals false and will 0. Wrong answer on last one. Shit. Everything else is correct, just the last one. I say 1, but the actual answer is not 1. Yes, initial state is only non-ambiguous. Okay. If A0 equals N, yes, if initial state is N, then LA equals false, and yes, L left would be equals false. Else if A0 equals 1. LA equals false and L left. Okay, in this case, this means everyone on the right is visible by this guy. And the current, I think the first one, I think the first one is should always be ambiguous. The first bracket, and yes, we are replacing bracket with capes because that is mathematical isomorphism. Replacing one model with another, which is easier to work with. 3 3 3 3 3. Why is this not good? 3 2 2. 3 means on the right there are two guys. The current one is can be anything, and but we are saying these both of these guys are visible by this guy, so they must have their brackets on the left, and we don't know about this one. And when we are here, this is saying, well, this one is visible, this one is visible, this one must be like this. And when we are here, shit, the answer should be one. No, no. This is fixing value for this, and that is crazy. This is fixing value for this. Here we are saying, yes, this one is ambiguous. We don't know about this state. But here, this one is not so ambiguous. That does make sense. Okay, so when we are here, LA last ambiguous was true and L left, yeah, its value didn't matter. When we were like here, we saw that this value reduced by one, decreased by one, which is one of the cases, which is case number this. When value decreases, that must mean left one was like this and the current one is also like this. That is cool. Which is this case when the value decreases by one, and if the last one was ambiguous, we make the current one non-ambiguous, and left bracket left is false. Okay, and then when we go in the loop again for the next time, we see that these two are same, and if the last one is not ambiguous, there has to be something. There has to be something. Okay, in this whole thing, we are always taking care of the things on the left, but we are not taking care of the things from the right. Hello, Wizard J wears his cap on his left side, and Wizard J wears his cape on his right side, and this, yes, that is the problem statement. Mm, okay, here we are taking care. When we are on current eye, we are making sure that this eye is compatible with everything which is on the left. All we have to add is this compatible with everything on the right? Yes. Yes, is this compatible with everything on the right? Okay, which we can do. Int r is a0 minus 1. That is beginning from the first bracket. This is how many brackets should have their capes towards to the r side, towards right. So when we are here at the end, if we see if last left is not, then we do r minus minus. And r, if we still, if r not equal to 0, that is r is positive or negative, then p equals false. What is that much? Okay. What is this? No, yes, this is like, no, this doesn't make sense. Yeah. Here, third last, third last, third last. 2. Yes, shit. We say okay, only this. If not LA, if the last one was not ambiguous, and not L. Yeah. This will also not work. Yes. If the last one was not ambiguous and it was not left, then reduce the number of R that we have, but also how many were ambiguous. That is something. There is not a lot of time left. Standing is also decreasing. So, and D is such a nice problem. I think you should try that one. Okay. Today's contest, nope. I want to first solve all of those 1600 rated questions. Penalty, penalty. Shit, yes, I forgot. No, in today's contest, there will be time penalty, right? For wrong submission. Tourist is shit. Touristing. D is nice. It- First, I want to solve this one. And I think this is just misleading. Answer can be 0, 1, 2. Ah, shit. Yeah, this does seem hard, difficult. This is an interactive problem. There are n 2 to 40 batteries numbered 1 to 3n, 1 to n. Some of them work while others don't. Let A be the number of batteries that work. It is guaranteed that A greater than equal to 2. A is the number of batteries that work, and it is guaranteed that A is greater than equal to 2. At least 2 of the batteries work. And you are given N but not A. Okay, there is a flashlight which can hold 2 batteries, and it only turns on when both batteries work. The batteries have been shuffled and you don't know which ones work and which don't. You can choose 2 batteries and try them in the flashlight. You want to find a pair of batteries that works. However, you are worried about breaking the flashlight, so you want to limit the amount of trials you attempt. Therefore, you should find a pair of working batteries at most n square by a lower limit tries. Okay, the interactor is adaptive. This means that whether battery this works is not fixed and may change during the interaction. However, it is guaranteed that there exists a configuration of A working batteries that is consistent with the information that you have received so far. Okay. Interaction. The interaction of each test case begins with the number n. To make a query, print a single line with 2 integers in the following format: UV, where U and V are numbers from 1 to n, indices of the batteries you want to test. Okay, I can check at a point if 2 batteries are working or not. And the most tries I can have is n square by A. And I know n, but I don't know A. N square 40. If 40 out of 40 batteries are working, then cool. Yeah, when all of the batteries are working, then also I would have n trials. There are a lot of trials, so that is cool. That is cool. And when A equals 2, I just have 2 batteries. And let's say n equals 6, 36 by 2, 18. I will get 18 tries. Okay. After that, read a single integer x indicating whether the flashlight turned on after inserting those 2 batteries. If x equals 1, the flashlight was on, otherwise not. After finding a pair of batteries that runs successfully, terminate. After printing each query, do not forget to output end of the line. Okay, after finding a pair of batteries that turns on, the interaction of the test case is considered successful and will terminate. After that, the interaction continues with the next test case. After printing each query, do not forget to flush and all of that. Otherwise, you'll get idle limit. If at any interaction step you read -1 instead of validate, I must have messed up. Someone got 2 test cases, 3, 1 and 2 off, 2 and 3 on. Wait, what do I have to output then? Then there are 10 batteries. Is 1 2 working? Is 1 3 working? Is 1 4 working? I have n number of batteries and the number of tries are n into n. Wait, let me go to the washroom. I'll be right back in a minute. Were you live? Yes, I am. live right now. But yesterday I was not. Yep, I'll be right back in a minute. Yep. And I think we can just exhaust all of the possibilities in this. Like when we have n batteries, and in the worst case, we will have to uh, check each battery with every other battery, and the total number of pairs would be n into n minus 1. Yes, that would be the total number of pairs, and the total number of tries that we have would be minimum. The total number of tries would be minimum when A equals the maximum thing, but also this is when we are and this is the total number of possibilities of pairs that we could make, and n divided by n into a divided by, this is a, n into n divided by a, that is the total number of possibilities. This is probability again, like random algorithm. I think if we just go with testing all the pairs, we should be happy. That would be nice. I think we can just go and test all the pairs with each other. No, we don't. When we are testing battery number 1 with battery number 2 to n, and if nothing works, then we know battery number 1 is like a retard, right? And then we go from by pairing battery number 2 with, and when we know that battery number 1 is not working, do we have any extra information about all of the other batteries? Nope. We do not have any information about any of the rest of the batteries. Yep, we do not have any information. We cannot say for sure. Yes, so we will have to exhaust all the possibilities. And yeah, let's exhaust all the possibilities. Huh. Error executing, no last change. Okay. Shit. Int and yes, we will be using flush and everything. And we can remove this. That is nice. CNN and bool, or let's say int x equals 0, and while while not x, what we will do is cout L equals 1, and R equals 2. L equals 1 and R equals 2. What we will do is for int I equals 1, I less than n, I plus plus. For int j equals I plus 1, j less than equal to n, j plus plus. Cout L or I space j and line, and cn x if x, then break, and if x, then break. Yeah, we just don't have to do anything else. And that is it, what we have to do. That is all. We output 1 1 1 2. Let's be the interactor. Let's say there are two test cases. First one has 3. Okay, 1 2 1 2 answer, we output 0, right? 1 3 we output 0. We will output true for 2 3. We will output true for 2 3. Let's say a n here and into n. What is the total number of chances we have? 3 divided by 2, 9 divided by 2, that would be 4. We have 4 possibilities. Yes, and we will output true for 2 3. Let's say 0 2 3 1. And now the new x is 10 1 2, and we will output true for 1 4. Cool, that does seem okay. And we have 18 minutes. Okay, if this works, that would be nice. If this works, if this works, if wrong answer on test case 1, that is very messed up. How? We will just wait. Shit, we have to output a new line. Otherwise, x will 0. After finding a pair of values that has and flush is, this is the only line that we are outputting anything. And yes, literally, maybe I don't get this problem. Yes, problem A. Problem A had a direct formula. That is crazy. 2 into n minus 2. Like 2 into n minus 1. I cannot see what is wrong with this. We are, how can this be wrong in test case 1? Maybe the format. We'll just output this. No, no. From here, there are two test cases. First one has 3, 0. No. Yes. 10. No. No. Yes. And exit. How is this wrong? And we are getting like literally wrong answer, not even some other error. Hacks are disabled for this. To flush, yes, we are flushing correctly. Cout dot flush, we are using end line which flushes automatically. If X, then break. If yeah, standing is just going down at this point. Wrong. Maybe I just don't get what I'm supposed to do in this one. The line of interaction, this it is guaranteed that n does not exceed. How can you are given n but not a? It is guaranteed that a is greater than equal to 2. Okay, some of them work, some of them don't. You are given n but not a flashlight using the minimum number of tries. There is a flash. Okay, makes sense. I have to determine the answer using the minimum number of tries. How can we even minimize the number of tries? There is a flashlight which can hold 2 batteries and it only turns when both of them are true. The batteries have been shuffled. You don't know which ones work and which ones don't. You can choose 2 batteries and try them. In the flashlight, you wanted to find a pair of batteries that work. However, you are worried about breaking the flashlight, so you want to limit the number of attempts. Therefore, you should find a pair of working batteries using at most n square by a trials. In the first case, n equals 3. So 3 square by a, and we do know that one of, yeah, that battery number 1 is like doesn't work. Battery number 1 doesn't work. Battery number 2 and 3 do work. and therefore there are only two batteries which are working, and yeah, so total number of tries would be 9 divided by 2, that is 4, and we are determining the answer in 3 tries. 1 2 we go, then 1 3, and then we have to stop. Shit, yes, then we have to stop because we do know. Okay, okay, that does make sense. So not just this, but we have determined if X break, or if I is the number of batteries which are not working, and which batteries are ambiguous, n minus I minus 1. This number equals 2, then also break. N minus I minus 1, I plus 1 number of batteries are not working out of I, so that we kind of like know for sure are not working. Okay, cool. Shit, that does make sense. That does make sense. Let's see. Hello. Also, I think it will take more than the number of tries this way. Remove last C out. Just flushing. So I think it will take more than the number of trials this way. It is problem D. I don't think it is just simple peer checking problem. I think now what I have written should kind of work. We don't know A, because whenever we have passed an I and and shit, I is one indexed, so that is nice. Whenever we go past an I and reach this line, we know either X is true, or this, that is the number of batteries we know which are ambiguous. This is the possible value of A, and if this value is equal to 2, which is the minimum value, so we know these remaining batteries must be working. That is what I'm going with, and yes, the thing that the last C out must be removed, that is nice. And yes, now I'm just blindly submitting, and if this is wrong, this might actually be wrong. Shit. This might be wrong. Why is it still running? Shit, I messed up something. I messed up somewhere. Okay. I added this end line here because there is an extra line here. That is why I added end line here. Shit. 7 minutes left. Yeah, nah, this ain't working. C. No. I guess idleness again. two test cases. First n is this, and we get 1 2. Nope, this is wrong. Nope, this also doesn't work. Now it says idle. Output 10. No, no, yes, and exit. Something is wrong. Yes, obviously. Idleness limit exceeded verdict. We don't forget to output end of line flush, which we do. And this thing is also doing the same. This is also doing the flush. Okay, let's manually do this. Flush, and here 4 minutes. If we do get a right submission, that would be very nice. If we do. Share. No, this is also not working. Nope, this is also not working. Flush. Idleness limit. It's the wrong problem. This should be right. At least we are not exceeding the number of test cases that we can go with. The error is because of this. Either x is true or n minus I equals 2, in which case we do know the answer. That is the last one. When does the program end? Works or not may change during the interaction. However, it is guaranteed that there exists a configuration of a working battery that is consistent with the information that you have received so far. You want to find a pair of working batteries. After that, read x 0. If x equals 1, the flashlight turned on and not. After finding a pair of batteries that turns the flashlight on, the interaction of the problem is considered successful and it will terminate. After that, the interaction continues with the next test case. After printing each query, do not forget to output end of line. Wait, after printing each query, do not forget to output end of line and flush. End of line and flush. If x is true, then break. 1 minute. There is only 1 minute remaining for this. Yeah, this ain't working. And shit, standings. This is bad, very bad. And you were able to do the third one. Shit, that is crazy. That is pretty cool. Yeah, we will have to review two questions now. Question number C and question number D. C and D. C is something and D is something. D should work. Should work. After sending out each query, do this, which we do. Yeah, I guess we can just read the editorial. Wait, is the editorial out for this? Yeah, cool. Shit, that was not very good. I saw the tourist solution. He checked for batteries if diff of 1, then 3, then like that, kind of like 2 pointers. Okay, like first the pairs would be at a difference of 1, then at a difference of 2, then at a difference of 3. That would also take the same time. Yes, yep. Shit, would that take the same time? When we are moving with a difference of 1, here, these two elements, and if this is false, then one of them is wrong. One of them is not working. And okay, then we move our pointer here and we are seeing this and this. And now we know that one of them is wrong, like not working. Okay, then we move our pointer and we are seeing this and this. Now we know that one of these is not working. And initially we knew that this, okay, we don't know its state, we don't know its. Could there be a case in which at least one of these is working? We know that this one or this one, either this or this is not working. Let's say this is the one that is not working. Yeah, that would work. If this is the only one that is not working, that would also work. We just know that there are no two adjacent batteries which are working. That is the only information that we know about. Yeah, I think these two should take the same time. Yep, bad performance. Shit, there is no editorial for this yet. We will have to read other people's code. Let's go to Mr. Giangli. And he didn't use end L or flush, end line or flush. So what is he doing? And Mr. Giangli is online right now. That is pretty nice. This was yesterday's. Yes. 6. Uh, and let's see. First one, 2 into n minus 2. And okay, let's just see why this works. 2 into n minus 2. This works somehow. That is pretty cool. We have n things in the winner. Okay, when will winner become equal to 1? Winner would become equal to 1 when, yeah, before, um, and when would the number of people in loser become 1? In the loser group, we have two groups, winner and loser. Everyone is here. Is every team paired up with every other team? Shit, each team is playing 2 matches. One team plays a match here. From n minus 2 teams are there, which are like out. They play one match here and one match here. So at least this many matches. 2 into n minus 1 plus the one team that stayed here and the one team that stayed here. They will play one match among themselves, and n minus 2 teams went out and all of them played 2 matches, one match here and one match here, and only then they went out. Now at last we have one team here and one team here, but shit, we have to say how many matches there were. Output for each test game, total number of matches played during the tournament. Total number of matches. A lot of these matches will overlap with each other. We know that the formula is 2 into n minus 2, but why is it that 2 into n minus 2? And there are total n people. Let's say for n equals 4. Initially in the winner group, we have 4 people and 0 people. The number of matches, this will become 2 and this will become 2. Cool. And we have had 2 matches here, right? And then this would become 1 and this would remain 2. Yes, and the total number of matches are 2 at this point. Like 2 more matches, so 4. And then this would remain 1 and this would remain 1. Total number of matches is 5. And then 1 match between this and this. Total number of matches is 6, which is actually true. That is 8 minus 2, 6. And at the end, we have 2 people who are outside of the tournament. 1, 2, 3, 4. Let's say 1 and 2 won the game, 3 and 4 lost the game. And then 1 won the game and 4 lost the game. 4 is outside, 2 and 3 are here. Then 1 is still here, 2 is here, and then 1 match between 1 and 2. At the end, we have 3 and 4 outside of the tournament, and 4 played a match, let's say, against 2, and 3 played a match here. That is cool. Then 3 and 4 played a match with among themselves. That is 1 more match, and these 2 also played a match. Why would the formula be 4 2n minus 1? That does not make sense. There are no ties and teams, cause the solution that I wrote, that is just simulating the whole tournament. Tourist was online a while, 7 hours ago. Solved 6. That is more than what I did. Only 2 questions. Shit, the third one is combinatorics related. Shit, laptop is actually going to die. Okay, for the first one, I think he also did the same thing. 2 into n minus 1. Okay, how are they reaching this conclusion? I guess I will have to read the editorial, and that would be it for question number 1. Let's move on to question number 2. El Functo. Ibrahim's great escape. And I think I did pretty good with this question. And how much time did I take on this question? If it is more than 20 minutes, then it is not very good. It is 22 minutes. Almost good. But also I gave wrong submissions. So yeah, that is not good. C. Yes. B. Let's see tourists submission for this one. K equals n into n minus k. That is pretty cool. Yes, yes, that is what we do. Then continue on to the next test case. Otherwise, you out yes. And yeah, for int I and j, if k greater than 0, then subtract 1. And if we are at like the top row, if we are on the top right corner, then see out R. that is go to the right. Else, if we are in the top row, then see out L. Okay. Else, if we are not on the top, that does make sense. That does make sense. So the loop, he is creating the loop on like the top row. Okay. And then otherwise always output down. Yeah, that is cool. That is cool. That is kind of what we do. We, in our solution, we are making the escape towards the top, but in his solution, he is making the escape towards the bottom. Symmetric solutions. Wait, these two cheated. No. Uh, okay. If yes, k equals n minus n into n minus 1, then C out no. Otherwise, C out yes. And if k is this, then yeah, yeah, that is right. He is making the escape to the right. Okay. Tourist made the escape towards the bottom, and we made the escape towards top. We have different ideologies. Otherwise, take the number which are like no, which don't go. Yeah, which are take the number of squares cells which do not lead to escape, and initially everything is to the right, and k minus minus due to some reason, and then for int I with 0, if we are if none of these are 0 and k is greater than 0, then we will go up or down if none of these are 0. So we do not. Okay. If j equals 0, that is we are in the first column, and else if we are not on the in the first column, then go left, and we will have a down somewhere. Wait, if we are in the first column, always go up. Everything initially is 0, and we are moving from the left. K is the number of cells for which answer does not exist. K minus minus, and if j equals 0, up, up. We are not changing the first square, the top left square. And okay, we are not changing the top left square. We are considering that it is already done, and k is at least equal to 2. We know that because we checked it here and here. So k is not equal to 2. It is at least equal to 2. So we will go in here, we do k minus minus, and if we are in the first column, then we go up. That makes sense. And if we are not in the first column, then we go left, left. That is true. Okay, cool. That is correct. Now we can move on to the third question. That would be nice. This is Mr. Giangli's solution. And this one is Mr. Tourist's solution. He uses debugger 42, the answer of the universe. It has been 2 hours and 20 minutes. That is nice. Fine. Okay. We take in n, and then we are filling our vector. And this is about the bracket question. Yes. And for int I, for x equals to, the answer is 0, and for x equals to 0. And let's, for even that, let's see. Test details. Is the answer ever greater than 2? Nope. Nope. Answer is never greater than 2. Answer is almost always 1. Yes. Yes. Answer is never greater than 2. At max 2. So that much we got right. That is cool. But we were unable to do this. X equals 0 and okay, if sum int sum equals a0 plus x minus 1, which initially is 0, so a0 minus 0, I think this is just how many brackets are on the right, or okay, and then vector p n plus 1. I think here Jangly is checking, is the answer possible when we suppose that the first bracket is opening, and is the answer possible if the second, yeah, that is what he is doing. Okay, if the answer is okay in both the cases, then that is cool. Okay, okay, if you begin by taking the first person as left or right, and then we check if it is okay with whatever, then it is true. Okay, let's go with this. Scene n vector and a site n for int reference x in a, c in x, and now what do we do? Yes, int answer equals 0, and uh, we'll do the same thing that he did for x equals 0, x smaller than 2, x plus plus, and x 0 means first is left, and x 0 means this, and x 1 means first is right. Now first is left and first is right, and then okay, if the first one is left, we will see, yeah, then the number of brackets on the right, and right equals it already is fixed, 0 minus, and in left equals 0. Int left equals 0, then we will start iterating from the second one. If I equals 0, I less than n, I plus plus, we will start iterating from the second one. And what does the second one want? If the first one is, if x is 0, x is 0, x 0 means that the left person, the first person has their bracket on the left, they should be visible by the current person. So if ai equals ai minus 1, if they are equal, then this current person should also have a bracket on left. L left equals x, or left equals not x. Yeah, not x. If brackets are same, if the number of things are same, then the left one has to be equal to the right one. And yes, no, they are not equal. L equals not L now. Now, if else if AI minus AI minus 1 equals 1, that is 1 increased. The current one increased by 1, and it's just means this, then wait, the answer is not possible, then false, then false, then false. Let's also have bool p equals initially true, and in this case p equals false. Else if AI minus AI minus 1 equals minus 1, that is the current one decreased by 1. I think that is also not possible. The last one, okay, this depends on the last one, whatever the value was for the last one. No, we are still doing the same mistake that we were doing earlier. By not checking every bracket on the right, we are only making sure that the correct bracket matches with the brackets on the left. X equals to 0, sum, I think is sum. X is 0, sum would mean here in this case, sum I think means how many brackets are on the right, which have how many people on the right are visible. How many people on the right are visible. Then pre n plus 1 prefix, okay, 0 to n, and I equals I plus 1, okay, and minus pre plus sum minus AI. That is very ambiguous. Okay, what are we doing here? Pre I plus 1. I think it would be just much better when we do read the editorial. After reading when the editorial comes out, we can read the editorial and then see what things are happening. That would be much easier. And let's see the solution for D. Takes in N. Okay, that is what tourist did. Exactly the same thing what tourist did. Take in N, okay, and ask is a lambda function, a referential lambda function. Takes in two integers x and y, and if not 1, then see out x plus 1 and y plus 1. X plus 1, y plus 1, and then int got, cn got If got equals 1, then 1 equals true. Okay. And then length 1. Ask this and this. So that is the only change. They have a distance length and see out this standard and length if x equals 2 then return. Okay. How does this work? Why we can like easily implement this one, but why we don't know why this works. In L equals 1, L less than n or equal to n, L plus plus. For int I equals 0, I less than or I equals 1, I less than equal to n, I plus plus. And not just this, what would be the right index? Right index would be I plus L minus 1. See out I space I plus L minus 1. No, L therefore has to be 2 initially, yes. I plus L minus 1 and yep, end line int x, c in x, if x return. The only thing that we have changed is the order that we are going through these pairs. And if this works, that would be kind of crazy. Submit code. Okay. D batteries. It is working now. Why? Okay, somehow this approach where we shit, what we wrote during the contest was our one pointer was here at the start. It was moving slowly and the other pointer was to the right and the other pointer was moving very fast while the first pointer stayed there, and when the other pointer reaches the end, then the start pointer moves by one block and the other pointer starts moving from there. But what they have written is we have two pointers at a distance of 1 initially, and then in the second iteration both of them are moving to the right, and this happens till this second pointer is at the last element and the first pointer is at the second last element. Then we start iterating from the first again, but now the distance between the pointers is there is one cell between them, so the distance is now 2, and they keep moving like this till the end while the second pointer is at the end and the first pointer is at the third last element. And this approach is somehow far better than this other approach. Like this is supposed to be bad and this is supposed to be good due to some reason, and I think we will be able to know that if we do read the editorial, which is not out yet. Editorial would help quite a lot. Yep. And is there something we can do right now? Nope, editorial is not out. That is done now. But the yes, performance is not very good for today's contest. Yeah, 5. 5,000 is very bad. Very bad. Very bad. Very bad. 5,000 is very bad. Which just means we have to solve a lot more questions than we are solving right now. And yeah, I don't think there is anything else we can do. One more thing that we will do tomorrow is we will do virtual contest for this contest, education round, this one. Yeah, I will not give this contest today. I will be giving a virtual contest tomorrow for this one. Because before giving virtual contests, the actual contests, I want to solve all of these 1600 rated questions. There are quite a few remaining. And after I have gone through these, I will give contests. But before then, only virtual contests. That is nice. And that would also be the end of today's stream. And if someone wants to see something, now would be the time. Because yep, now I will be ending the stream. Yes, today was not good. Final standings. This was not good. Problem B from yesterday's contest gave me so much trouble. What is the best way to approach it? Okay, in problem B, it's problem B I was able to solve, so that is nice. Okay, the basic approach is you need to have two blocks side by side which are pointing to each other. Shit, that is wrong. Which are pointing to each other. If you reach this block, you will go here, and if you reach this block, you will go here. So this is a loop, and that is just all you want. And the general idea is just this. So you need at least two blocks which through which you will not be able to reach a end. And since k is the number of blocks cells from which if you start you should reach the end, and in total there are n square blocks, then n square minus k is the number of blocks from which you will not reach the end, and this number has to be at least like, yeah, this can be 0, this can be 0, in which case you will be able to reach every possible place you want to. But if this number is exactly 1, that is, you just want one block, one cell from which you won't be able to reach the end. Answer is not possible, in which case you will output no. But when the answer is possible, now is the question how you construct the answer. And what I did is, let's say you have a grid like this, and out of this grid, you need k cells from which you won't be able to reach the end. And when I made this grid, I initialized this. Yep, n by n grid. N by n grid where everything initially is pointing up. So initially every cell is pointing up, and in this case, if you start from any cell, you will get out, and that is okay. Now you want to make k cells out of these such in change in such a way that you won't be able to reach out. And what you can do is, let's say you want, since you know that k is either 0 or at least 2, right? Then what you want is, let's say if k is greater than n, if n is smaller than k, then it means there are some rows in which you want all of these cells, such cells that you are unable to reach outside. So you can, if you just turn this top cell down, then this whole row, no matter where you start from this whole row, you won't be able to reach outside, and that is cool. So for the number of rows, like for k by n number of rows. These are the total number of full rows from which you don't want to reach the outside. So for this many rows on the right side, you change their top to be equal to d. And if there are some rows here, which like if there is some remaining number of cells left, which should also be like unable to reach outside, then they are going to be some proportion of this thing. Here you can just turn these right so that you will go here, and from here you will just end up in a loop. And I hope that makes sense. Cool. You mean n square minus k? Yes, n square minus k. We can make a solution if no, we cannot make a solution when n square. No, we cannot make a solution when n square minus k equals 1. This would mean we just want one cell in such a way that we are unable to reach outside. And where would you even place that cell? Like from this cell, you will have to go to some other cell, and all of the other cells are such from which you can reach outside. So yeah, it's like the answer is not possible in that case. Yes, that helped me a lot. Okay, you're welcome. I'll give it a go tomorrow morning. Thanks. I didn't think to initialize every cell to an escaping cell. Yeah, that is something that is kind of cool actually, that we can do that. And yep, that would be it for today. If there is something someone wants to say, that would be nice. And wait, monkey type. Let's see. Okay, I will totally mess this up. The typing speed, I will totally mess this up. Ah, shit. That is bad. That is bad. No one saw that. Okay, and that would be it for today. And seems like no one has to say anything. That would be okay. And yep, thank you for being here. This would be the end of today's stream. Thank you for being here. Bye.